Hey everyone, today we're going to do a quick video on exponent laws and just go over the distributivity rule in the numerator here, and as well as a few exponent laws that'll lead us to our simplified version of this expression, okay? So to start things off, let's simplify this monomial to the power of 4, and I'm going to look over to our first exponent law that says whenever we have a power raised to a higher power, we can combine the exponents through multiplication and simply have that x to the power of a times b. That is the product of the two exponents. And so if we apply that law into our first part, we're going to get 2y squared, all of that to the power of 4. And so the power of 4 taps onto the 2 first. 2 to the power of 4 is 16. And then we have y squared to the power of 4. Y squared to the power of 4 means y to the power of 2 times 4, combining the two exponents into a product. And so we'll have y to the power of 8. And we still multiply through the binomial that follows. And then we can use again this first exponent law to simplify our denominator. So we have 2y cubed all to the power of 3. So the power of 3 hits the 2 first. 2 cubed is 8. And y to the power of 3 to the power of 3. We can multiply the two 3's and we get y to the power of 9. Next up, we can multiply through our binomial with the monomial here out front. And so first off, the exponent 16 times 8, that starts us off with 128, and y to the power of 8 times y cubed. I'll remind you of your second exponent law that'll be useful here. Whenever we multiply the same base, we can add its exponents. So again, multiplying y's, we just add a plus b as the final exponent. Applying that rule here, we have 128 times y cubed. We have the same base, both y's, and so we can add the 8 plus the 3, providing a y to the power of 11. And then the second term inside the bracket, we'll have 16 times 5 minus 80. Y to the power of 8 times y to the power of 2. Again, we have the same base, so we can add the exponents together, giving us y to the power of 8 plus 2, y to the power of 10. All of that still over 8 y to the power of 9. And then, since we have two terms over a common denominator, we can write these separately. So we can write this as 128 y to the 11 over 8 y to the power of 9 minus 80 y to the power of 10 over 8 y to the power of 9. And then we can simplify each term individually. And I'll remind you of a third exponent law that will be useful here. Whenever we have y to the power of a divided by y to the power of b, that is to say, whenever we divide the same base when there are exponents at play, we can write this simply as y to the power of the top exponent subtracting the bottom exponent. And so y to the power of a minus b. And so if we apply that here, we'll have 128 divided by 8. That will give us 16. And we'll have y, as because y is present in both terms, y to the power of 11 minus 9. 11 minus 9. And so that gives us a y squared term. And then subtract 80 divided by 8, so the coefficient of this term is 10. And likewise, subtract the exponents. So we have y to the power of 10 minus 9, which is just y to the power of 1, or just y. And so in the end, our more complicated expression simplifies down to 16y squared minus 10y. And there we have it. Okay? I hope that helps. If you guys have any comments, suggestions, requests for future videos, please leave a comment down below. And thanks for watching.